Hello, and so now we're going to be looking at this last problem that kind of gets into this table and whatnot, and just to build up your understanding a little bit more. So if we have n is equal to 8, x is at most 2, and p is 0.04, again, first things first, we got to have our p's and q's. So we should be able to get our q, which is 1 minus 0.4, which I think we can do without a calculator, and we get 0.60. So we have that. Now, the other thing to keep in mind is that because we're using the table, technically we don't need q. So why I found it, I don't know, but just in case, it doesn't hurt to have it in case you want to use the formula. So now the other part is to break down what at most 2 means. So remember, we want those specific cases of x. So in this case, we want the left side of 2, so 0, 1, and 2. So we want to include 2 with at most. All right, so now we have those. So if we are looking at those individual probabilities, so at most 2, we want the probability of 0, probability of 1, and the probability of 2. So if we use our table, we can find those values. So we have our table, and then we can go down to n equals 8. There it is. All right, so we need 0, 1, and 2, and we specifically need it for p equal to 40%, so 0.40. So 0.40 is right here. So we're going to stay down this column, and if we look, we need this probability, and this probability. So 0.017, 0.090, and 0.209. So let's write those down. 0.017, and we want to add 0.090 and 0.209 for a grand total of, now we should do our calculator just to be safe, 0.017 plus 0.090 plus 0.209 equals 316. So 0.316. So that should be our answer. Now, if we looked at this next one, this then says at least 2. So now we are looking at 2 and up, and we have to go all the way up to 8. Now, remember, if we have a lot of individual cases that we have to identify the probabilities for, it might be easier if we look at what's missing from the list. So remember, you're always looking at from 0 to n. That's the complete list. If you have all of those probabilities from 0 to 8, in this case, it would have to add up to 1. So we're looking at quite a few of them, but the ones that are missing is just 0 and 1. That's my weak attempt at doing an ampersand, but 0 and 1. So it's going to be to our benefit to use the complement to find this probability versus looking up all these individual probabilities. So we're going to want to say, I'll write out the whole thing. So if we want the probability of at least 2, this is going to be equal to 1 minus what's missing, probability of 0 plus the probability of 1. Now, we already have 0 and 1 on this side, so we know this is the probability of 0, we know this is the probability of 1, so we can just combine those pretty quickly. So that looks like it's going to be 0.107. And so now when we subtract those, we're going to get 0.893. So that's going to be the faster way to do some of these problems. So really be careful on how you analyze these phrasings, at most, at least, more than, less than, because it's going to be important as far as minimizing your work, or otherwise you're going to be putting a lot of effort in that you don't really need to. All right. So let's do this last word problem. Same style of questions, but just more wordy. So we have to be careful when we pick out that relevant information. So based on a Harris poll among adults who regret getting tattoos, 20% say that they were too young when they got their tattoos. Assume that 5 adults who regret getting tattoos are randomly selected and find the indicated probability. So let's maybe write down some of our relevant information over here. So if we know N, now X is going to change depending on the specific question. So I'm going to leave X out, and we can kind of show it, but we're not going to fill that in generally for the whole problem because, again, it's going to change. But our P and Q should stay the same. So our N, P, and Q should be concrete. So what would N be for this problem? Assume that 5 adults. So our sample size, or our number of trials, is 5. X, again, we're going to leave out because it's going to be dependent on each question. P, though, should be what? What's the chances of success? So remember, success in this case means that people regret getting tattoos. So 20% are regretting it. So that is going to be our 0.2, which is 20%. And so Q must be the other 80%. So those are our fixed variables for each of these parts. So for part A, we have find the probability that none of the selected adults say that they were too young to get tattoos. All right, so what does none mean to you? How many is none? Yeah, if it's none, X is going to have to be equal to 0 for this one. Now, it doesn't specify which process you should use, if you want to use the table or if you want to use the formula, but in general, you want to try, if you're given the choice, I would try to use the table because it's going to be much, much faster. Looking at our N, it's small, so that's going to be on our table, and 20%, 0.2, I believe is on our table as well. So we can use our table. So the probability of 0 is going to be equal to, let's see, N is 5. So yeah, N is 5, X is 0, we want 20%, so 20% is right under here. So 328, so 0.328. Done. All right, so roughly 32.8% of the people thought that they were too young, if none selected that. That happened 32.8% of the time. Find the probability that exactly one of the selected adults say that he or she was too young to get tattoos. So now we can clearly see that X equals 1 for this case. So if we want the probability of 1, let's go back to our table. So we got 5 again, 1, and 20%, so 0.410. So 0.410. Okay, C. Find the probability that the number of selected adults saying they were too young is fewer than 1. Fewer than 1. So what is X going to be for this case? Fewer than 1. Well, there's not much fewer than 1. The only thing fewer than 1 is 0. So in this case, it's the same as part A, which is kind of silly. But that's the answer. Now, for part D, if we randomly select 5 adults, is 1 a significantly low number who say that they were too young to get tattoos? So now for D, is 1 adult significantly low? Now remember, to answer this question, if you're looking at significantly low, now we don't have any means or standard deviations or anything like that yet. So the only thing we can look at is probabilities. So in this case, we have to look at the probability of 1 and all probabilities below it. So really the question is is the probability of 1 or less than 5%, less than or equal to 5%? That's the question. Well, we can answer that though, because we have the probability of 0, we have the probability of 1. Those are the only two that are going to be less than 1, less than or equal to 1. So probability of 0 plus the probability of 1, not 0 again, is equal to the sum of those two, which is pretty large, 0.738, which is way bigger than 5%. So 1 is not. One adult is not significantly low. All right, so again, that 5% rule can apply to these situations, but be careful. Look at that number and less if you're looking at significantly low, and the probability of that number and higher if you're looking at significantly high. All right, so we're going to stop here and we'll pick up more parameters and things like that in the second half of the section. See you in a minute.